Good morning. Today we're going to talk about solving rational equations. So I'm just going to go over what we did yesterday in class. So when you have a very simple one like this, you could simply just cross multiply. Everybody knows how to do that, so I'm not going to go over it. The other way you can do this is to get your denominators to be the same and then drop them. So it's clear that the denominator should be 10. So in order to make the denominator to be 10 on this one, you want to find an equivalent fraction. So I basically will do it the way we're going to do it because it's going to get harder. Okay, if you multiply both sides by 5 over 5, this by 5 over 5, this becomes a 10 and then this becomes a 5. That's the same thing as doing an equivalent fraction. Nothing had to happen here, so we're just going to bring it down. Okay, now you can drop your denominator. And you're left with 5 is equal to x plus 1, so x is going to be 4. Okay. The other thing you can do, and it does the same thing as dropping the denominator, is to multiply both sides by the common denominator. So again, the common denominator is 10, so we're going to multiply this side by 10, multiply this side by 10, and we end up with 10 over 2 is equal to, these two guys cancel out, x plus 1. Well, again, what is 10 over 2? 10 over 2 is 5. So again, once we work it out, we get that. So you can do both of those methods. All right, let's try another one that's a little harder. Again, you can cross multiply. I'm not going to go through that method with you because you know how to do that. You've done that a lot. So let's get our denominators to be the same and then drop them, which is basically the same as multiplying by the other guy. So if you were doing this, you would do 2x plus, oh, I'm sorry, minus 3, right? And then over 2x minus 3. See what's going to happen? You're going to get the same denominator. So if you just multiply by the other denominator, when you only have 2 of them, it's no big deal. Okay, that doesn't change the value of that. So our common denominator, and you don't have to write all this out because this is a lot of writing. In fact, I'm going to pause and okay, I wrote it out, but really, for what reason? There is no reason to write it out because I'm just going to throw them away anyway. So really, we just want to deal with our numerators. So this is going to be 3 times 5 minus 2x. And this is going to be 1 times 2x minus 3. And then dropping our denominator, oh, that's not erase, here let's erase. Dropping our denominator, you really don't need it. And you could have just written it like that, because if you would have filled this in up here, like you can see those denominators are the same. So you don't need to really do much. All right, then solve it from there. I'm going to go really fast because you know how to solve these equations. All right, so I worked it down most of the way. Once you go ahead and solve for x, you get x is equal to 18 over 8. And then you plug that back in and it becomes 9 over 4. Now you want to go back into the original equation and make sure that your denominators do not equal 0. So if you go back in here and you plug in a 9 over 4 for either of these two denominators, all right, you get 2 times 9 over 4 minus 3. All right, so I think that's not going to be 0. That's going to be 18 over 4 minus 3. Does not come out to be 0, so that one's good. And then you do this one, 5 minus 2 times 9 over 4. We just want to make sure that our answer is not going to be extraneous. So 5 minus 18 over 4, definitely not going to be 0, so it's okay. So our solution is 9 over 4. All right, let's try another one. All right, so this one, oh, you've got quite a bit you can do. You could get all of these denominators to be the same and then cross multiply, or you can get all the denominators to be the same and then drop them. Okay, so whatever method you want to do, all right, is fine with whatever, as long as you're doing something mathematically sound. So I'm going to go ahead and get I'm just going to get my left side denominators to be the same. Okay, so on the left side, what does 2x and 5x both go into? I think they both go into 10x. All right, so what are you multiplying this by? Well, if you did this, is 5 over 5, right? That's going to make 10x, so we put a 5 in here. And then if we did this, 2 over 2, that's going to make 10x, so we're going to put 4 here. And remember, this is still all equal to 1/2. All right, I'm not changing that yet. So now these denominators are the same. Can't really drop them because they're not all in the same equation, so you just got to put them together. 5 minus 4 is 1 over 10x is equal to 1/2. All right, you can go ahead and cross multiply, or you can go ahead and multiply by the other guy. I'm just going to multiply by 10x, and I'm going to multiply this by 2. Look what happens. It's very easy. All right, actually, I'm going to multiply it by 10x because that gets a little complicated if you don't. All right, because it looks like 10x is going to be the common denominator. And you get 1 is equal to 10x over 2. Okay, which is really 5x is equal to 1, so x is 1/5. That's confusing. Then stick with cross multiplying. If you get down to this point and you can just cross multiply, you can do that. All right, and you can get 10x is equal to 2, and so x is equal to 1/5. All right, and then you go back in and you see if that makes sense. Can you put a 1/5 into either of these? Oh, yeah, you can. 5 times 1/5 is 1. It's not 0, so it's good. All right, let's go try another one. Now this one gets a little bit more complicated. I'm going to pause. Okay, I just had to move my screen because it was looking a little bit off center and it was a little confusing, and I'm going to fix this so it doesn't look so weird. All right, so okay, yeah, again, you can cross multiply, but you'd be multiplying too much stuff. So let's go and I'm going to factor this. So this is going to become 2 times x minus 1. And this is 15. And then you multiply x minus 1 times x plus 1. And then really, just to get all your denominators the same, this is going to be x plus 1 over x plus 1. This is going to have to just have a 2 in it and a 2. So if you notice, all the factors match up. So now, that's pretty messy. All right, you can drop them. And if you can see what I'm writing, it's kind of messy. Hold on. All right, I'm taking this 5 times x plus 1 and bringing it down. And then I'm bringing the 15 times 2 and bringing it down. And remember, they're equal to each other, and these guys are all the same, so we drop them. All right, and we get a lovely little, I've got some weird stuff going on here. All right, we get, I'm trying to get this to me, okay. So go ahead, 5x plus 5 is equal to 30. All right, 5x is equal to 25, and x is equal to 5. Now, go plug that back in and make sure that it works. So let's plug it back into here and see now. Remember, we got x is equal to 5. So 2 times 5 minus 2, that's just 8, so that's good. And then 5 squared minus 1 is 24, so that's good. Works out well. All right, if you were in the group that likes to cross multiply, this is okay. You can do it. You will just end up with something that will be factored, and you'll end up with 2 answers. So you'll end up with 5 times x squared minus 1 is equal to 15 times 2x minus 2. And then you've got to go and solve it from there, okay? And, sometimes it has to be done. But in this case, you didn't need to. Let's go on because I'm trying to beat the clock here. All right, we're going to solve this one. Hold on, let me center. Okay, so this problem looks like it's going to be very complicated, but I have a feeling it's all going to simplify out. So I am going to go with the method of getting the denominators the same. So the denominator of this guy right here is 1. So what would be the common denominator of 1? A squared. Now remember, this is a plus 1, a minus 1. And then this a plus 1. So I'm thinking a squared minus 1 is the common denominator. So I am going to get every body to have an a squared minus 1 in the denominator. So the very first term was a. I brought that down, and then I multiplied a squared minus 1 on the top and the bottom, equivalent to the same as it was. This one is already a squared minus 1, so we don't have to do anything to it. And then this one has just an a plus 1, so we need an a minus 1 to go with it. Because you know that's going to end up being a squared minus 1. So we're going to put an a minus 1 and then have a squared plus a plus 2. I was thinking that was factorable, but it's not. So let's see what happens. All right, so we've got to erase all of this. I am going to combine my like terms. I'm running out of time on this video, so I am going to do it. I'm going to press pause so I don't take up time and you don't spend time watching me combine like terms. Okay, so I distributed this first and I got this little thing down here. Then I did like a weird version of FOIL where you had to multiply all these things together and I got that. Now I'm going to start combining my like terms. So give me a minute here. Go ahead and check your work. Okay, so all I did basically was rearrange some things. I canceled out my a squareds because one's positive and one's negative. Thinking I'm doing this right. It's kind of late. It's about 10 o'clock at night. Now, if I'm going to subtract a cubed from both sides, look what happens. It goes away. So I'm just going to cancel them out. And I'm going to move all these guys over to the other side so that I have a quadratic. So I've got a squared here. I'm going to subtract an a and subtract an a, so that's minus 2a. Add a 2, add a 2, so that's minus 3 is equal to 0. All right, so it looks like we're going to be factoring. So let's go and factor this. It's very simple to factor. Okay, so once I factored and solved it, I've got a is equal to 3 and a is equal to negative 1. Now, we have to go back and check these. So let's go plug these back into the original equation. I'm going to scroll all the way up. What was it? 3 and negative 1? All right, I'm going to erase them. Okay, so we're checking to see if 3 works. It looks like 3 is going to work. 3 squared minus 1 is 8, and 3 plus 1 is 4. Yes, 3 works. But I can already see that negative 1 is not going to work. Negative 1 squared, okay, minus 1. I'm doing this one right here. Negative 1. All right, that's going to be 0. All right, and then negative 1 plus 1, that's also going to be 0. Can't work. All right, so our answer is just a is equal to, was it 3? Yes, a is equal to 3. All right, so your assignment is going to be to finish up all those problems that I gave you the other day, and they are all due on Wednesday. All right, have a great day.